Awesome. Well, so my name is Quinn Hlus, as Nicole said, and I'm going to be presenting on comparing two different breeding bird monitoring methods. I was able to do my practicum with Husky Energy's upstream environmental team in Lloydminster last year. So we'll get started with a bit of an overview. Why won't my slides change? There we go. Okay. So introduction, we will go through an introduction, we'll go through my background information, we'll go through my study objectives and methods, and then I will present my results and discuss them, and then I will leave you with my conclusions, recommendations, and acknowledgements. So anybody who knows me knows that I am not a bird person. I'm not really a fan. So you might be asking why I would do my capstone on birds. So this was the first year that Husky decided to use ARUs in conjunction with point counts for their breeding bird monitoring program. So I just thought it would be really interesting and really relevant to compare the two methods. Just with our industry, we're always looking for ways to do things more efficiently, more effectively, and I just kind of wanted to see how the two methods would compare to each other. So that was sort of got the gears turning in my head. So bird monitoring has typically been done using point count surveys. That's been sort of the traditional way of doing things, but ARUs have been kind of gaining speed, proposed in literature as additional or even alternative monitoring tools. And we'll kind of get into some of the advantages and disadvantages of both soon here. So river valleys, the importance of river valleys really can't be overstated. They're that interface between land and water, and they're just so relevant to be monitored just because they can support so many species in ways of providing habitat, providing breeding grounds. So it's really just kind of an important habitat to understand your impact on. And the river valleys are heterogeneous, however you want to say it, habitats. So that kind of transitions into my next slide here, just sort of stating how habitat heterogeneity really contributes to or supports species richness. So to put it simply, if you have a habitat or an area that consists of some grassland, some forested habitat, and maybe some disturbance in some river water, you're going to have more species occurring in that area as opposed to an area where you only have, say, grassland habitat. And that's just because your habitat is more complex. So when you have industry occurring in the river valley, so Husky has some industry, some disturbance in the North Saskatchewan River Valley, and sort of the different disturbances you're going to see there consist of some well pads, some vegetated versus non-vegetated access roads, and some facilities along the river. And so Husky implemented their biodiversity monitoring program a few years back just to understand what their impact, if there is any, on wildlife in the North Saskatchewan River Valley. And just because of that importance of sustaining river valleys, just because of what they can provide to species occurring there. So ARUs and point counts, kind of the two main bird monitoring methods used in current practice. So there are advantages and disadvantages to both. ARUs kind of have a huge advantage where you can program them to record however long, however many days, weeks, months you want them to record, and however long each day. And you take them out to where you want to set them up. You can forget about them, and then you come back when your study's over and you collect them. And then you have hours and hours of recorded data that you can come back to and reference for years later. Another thing, I just combined very and fairly. They're very low disturbance just because you do one in, one out to deploy and collect them. And a disadvantage of human observers is that they can sort of vary in their abilities to detect species. So some may be more experienced, better trained than others, so you kind of can get some bias that way, and it's a little bit more of a disturbance to the wildlife, to this plant species. So the one main advantage, though, that human observers do have over ARUs is their ability to detect species visually. Obviously, ARUs are only limited to auditory detections, so that's a huge difference between those two methods, that humans just have a couple more different means of detecting species. So my objectives for this study, I wanted to determine if ARUs can detect as many or more bird species than point counts. I also wanted to see which method is more effective for evaluating species richness in bird populations in the NSRV. And I wanted to see if habitat type influences ARU success when compared to point counts. And that comes back to that habitat heterogeneity. So get right into it with some methods. So I had 21 sites in total, and they spanned about a 100-kilometer distance in the North Saskatchewan River Valley. And so each site looked something like this diagram on the left here. So each site would have about 7 to 16 point count survey locations and 2 ARUs. And I'll explain the reasoning for that in a bit here. So point count methods. The Saskatchewan Ministry of Environment Forest Bird Survey protocols were followed to complete the point counts. So 2 observers would arrive on site, they would wait a minute for the birds to settle and get used to their presence, and then they would record all species seen or heard during a 10-minute observation period. So 3 rounds of point counts were conducted at each site. So that meant for a total of 30 minutes of sort of observation period per point count location per site. Like I said, there were 7 to 16 point count survey locations at each site, and the surveys were conducted between May 28th and June 26th, 2019 at sunrise, always in the mornings. So ARUs methods, there were 2 ARUs placed at each site. And so the Alberta Biodiversity Monitoring Institute suggests that ARUs be set up 4 of them in a square pattern. However, just due to the long linear shape of our study area along the river, it was decided that only 2 would kind of be relevant. The top 2 of the square would just sort of be out of the study area. So there were 2 ARUs at each site. So they were programmed to record for 10-minute periods hourly for 4 hours at sunrise and then again at sunset. So that meant a total of 80 minutes per day per ARU of recording time. And the ARUs recorded from May 27th to July 8th, 2019. So they were out there for a couple of weeks. And this is just a little sound recording of the ARUs. Yeah, just a little recording that they took. So I'm going to ask at the end what that bird was that was calling. So the habitat mapping portion. So the habitat mapping I actually did after I got the initial results of my study. And that was just because in the initial results, which I'll explain better later, the point counts performed way better than the ARUs. The ARUs paled in comparison, did not detect near as many species as the point counts did. And that was really confusing just because all the literature, or most of the literature that I had reviewed, kind of pointed to ARUs being the superior or equal method. So with the habitat mapping, what I did was I mapped every single point count location and every single ARU location for each site onto Google Earth. And so this is a Google Earth image that you see here on the left. And this is just one site as an example. So as you can kind of see, the point count locations are occurring in different habitat types. Like you've got one up here in some cultivated land, some are occurring along access roads, some are near disturbance, some along the river's edge, whereas the 2 ARUs on the site are pretty much limited to just along the river's edge. And so that kind of got me thinking that with the habitat heterogeneity concept, that the ARUs weren't in places where all of the habitats on that site were represented, because all of the point count locations were placed in different habitat types. So it made sense that there would be more species detected by point counts. So what I wanted to do is, instead of compare all of the data from all of the point count surveys at that site to the data from the 2 ARUs at that site, instead of doing that, I took that and scaled it down and localized it so that the data from just 1 ARU at that site was being compared to the data from just 1 point count location at that site, the survey. So it's kind of better explained here. So what I did was I drew a 100-meter buffer around each ARU location on Google Earth. And then I drew polygons around each habitat type existing within that 100-meter buffer using this legend that I created in the top right corner of the slide. From there, I used this calculation to determine what percentages each habitat type made up within that 100-meter buffer. And so once I had that information for each ARU, I was able to find a point count location on that site that matched the ARU habitat percentages the closest. So that is kind of illustrated in this slide. So I was always looking for the one that would match it the most in habitat makeup. So in this picture on the right, sometimes I got lucky and there was a point count that was located really close to an ARU, and they had so much habitat overlap that I was able to compare those, and it was a really easy decision. But in other cases, I had to look a little bit further away from the ARU across the site just to find one, because I wasn't necessarily looking for the one that was within the closest proximity to that ARU, but I was looking for a point that had the most similar vegetative makeup, the most similar habitat percentages to that ARU. So then from there, I was able to compare just the data from the 1 ARU to the data from that 1 point. So these were my results for all of my sites. So in total, I had 125 species detected. That's a lot. By both methods combined, and the point counts detected 117 of those species, and ARUs detected 78 of those species. And like I said, this was sort of confusing for me, just as I'd expected ARUs to perform a lot better, to detect as many or more species than point counts, and that is why the habitat mapping portion of my study was incorporated, to understand why. So those were my all sites. And then this is a box plot I made just to kind of further show you how it was split up by site. So at each of the 21 sites, both methods combined detected the highest number of species, both methods combined. And that was followed closely by point counts. Between ARUs and point counts, each of the 21 sites had point counts detecting more species than ARUs. And then over here on the right-hand side, these box plots are just to kind of show what species were unique to point counts and unique to ARUs, just as a little bit of extra information. So with my habitat mapping, I was able to take this chart on the left. And so this chart on the left, what it's showing you is a total site comparison. So all of the species in the point counts column, that is all of the species that were detected by all of the point counts on that site. And then all of the species in the ARUs column, that's all of the species that were detected by the 2 ARUs at that site. So I was able to take that comparison and localize it down to just the 1 ARU, the data from 1 ARU being compared to the data from 1 point count survey location. So then I ended up having 1 chart for each of the 21 sites to having 2 charts for each of the 21 sites. And that obviously made things more comparable, which I'm going to go into here. But these yellow highlighted cells, what those are visual detections. So those were species that were detected visually by human observers while conducting point counts. I wish I had a little bit more time to talk about that, but I would be happy to answer any questions about visual detections at the end. So my results of my habitat mapping, so because I had 21 sites and 2 ARUs per site, I should have had 42 comparisons Unfortunately, there was an ARU removed at one of my sites. Dang. So I only had 41 comparisons, but that's okay. So 26 of those cases had ARUs detecting more species than point counts. 12 cases where the point counts detected more species than ARUs, and then 3 times where they detected the same number of species. So this was a little bit more along the lines of what I was expecting. ARUs kind of pulling ahead when we accounted for the habitat that both of these different methods were being completed in. So some discussion. So the two methods unfortunately couldn't be compared on the basis of time frame. So by that I mean the time of day that the point count was performed, comparing that data to the closest time period that the ARU was recording that day. And that was just due to limitations with the data and kind of time frame. I was in a bit of a time crunch to get this done, and the data came a little bit later in the year. So I would have loved to have looked into that a bit more, but unfortunately, that meant that a true comparison wasn't able to be made just due to the large difference in those survey hours between the methods, because your ARUs are recording for 80 minutes per day, and they were out there for weeks. So you have just hours and hours of data that these ARUs have produced, whereas each point count survey location only has 30 minutes total of, I guess, observation data. So there's a huge difference in those detectable hours. However, a huge advantage of ARUs is their ability to record for longer lengths of time and collect extensive amounts of data. So it could be argued that that isn't really a factor in comparing the two, just because that is a huge advantage of ARUs. So given the difference in those detectable hours, it was expected that ARUs would detect more species than point counts. However, there were those 12 cases where point counts detected more species than ARUs, and 3 where they detected the same number of species. So that just kind of reinforces the importance of having human field observers out in the field, just because they can use those subtle cues in combinations with sounds in the field. So those subtle cues being the species of plant that a bird is calling from, the height of the sound source, and also, of course, visual cues, as obviously ARUs are only limited to the auditory cues. And according to one of the sources that I used in my literature review, they said that humans can detect birds at greater distances than ARUs, which could have also contributed to those few cases where point counts detected more than ARUs. That's also an idea that I wish I could have explored a bit more, but it's just too big of a topic to look into. So kind of the main discussion point being that both methods provide different levels of information. Both are still really valuable, obviously, in my 2 different comparisons. So to conclude, I just wanted to come back to my objectives. So my first objective being, can ARUs detect as many or more bird species than point counts in a given area? And I would say not in a consistent way, but if the habitat characteristics are being considered in your comparison, then there is a better probability that they can detect or be comparable with point counts. Which method is more effective for evaluating the species richness? For that one, just because my results of the 2 portions of my study were so conflicting, I can't really make a clear conclusion, but both of the methods combined obviously produce the larger species count than any one method alone. So if I had to pick, I would say the 2 methods combined definitely gives you your most accurate, thorough information, species richness data. And does habitat type influence ARU success when compared to point counts? Yes, absolutely. The ARU data became way more comparable to the point count data after accounting for the effect of habitat type with my habitat mapping. So in conclusion, both methods are really valuable in their own unique ways. I would say at this point, ARUs can't really be used as a standalone method, but they do complement point counts really well and just kind of supplement information maybe where point counts are lacking a little bit. So my recommendations, I would love to see another study where all of the habitat types are represented in the ARU surveys. I would love to see a future study that considers the placement of ARUs in different types of habitat. So whether that means that ARUs just need to be placed a little bit more strategically so that they're in areas where there's sort of some habitat overlap, or whether that means that you just need to have physically more ARUs on that site to kind of understand your species richness. I would love to see a future study consider that. And I would also recommend that for future bird monitoring programs to consider using both methods in conjunction with each other, because that obviously gave the most species total than one method combined. So just a few acknowledgements. Big thank you to Husky Energy for taking me under their wing and giving me a great place to do my practicum and giving me lots of exposure. I'm really grateful for my 8 months with them. Thank you to Nicole, Darcy, and the rest of my instructors. Nicole, you have worked so hard. You should be so proud of yourself, and we're all very grateful for everything that you've done for us and having us still be able to present our capstones. It really means a lot. Darcy, the bird wizard, thank you for all of your help with all of my bird questions, and all of my other instructors that helped me along the way. Thank you to Lakeland College for giving me a great place to finish off my education. And thank you to a couple of people that at Xterra Environmental Services. They helped me a lot with my bird data, and Randy and Kirsten, I'm sure they're tired of seeing my name pop up in their email, but they were definitely a big helped me along the way. So big thanks to all of you guys. And here are my references. I had about 1 million of them. And are there any questions?
Good job.
Everyone should unmute and clap. Thank you, Kaden. Are there any questions for Quinn?
I got a question.
Mm-hmm.
How much does one of those ARUs cost?
Ooh, you know, you got me there. I do have a document where it says how much they cost, and I don't have it with me. I was planning to actually incorporate a bit of a cost estimate between the two methods into my original capstone. I hear a dog. But unfortunately, I just didn't have the time to incorporate it in. So, but I can definitely look that up and get back to you today.
I'm sure I can do it too.
I know where it is.
Yeah. All right. Thanks.
Mm-hmm.
Hey, Quinn, strip it. In your opinion, did they put the ARUs in the right spot? Would you move the spots along the river valley? Are they in areas where there are another question would be areas where there was cattle around, and did that affect the number of breeding birds? I'm just curious. I know we've had other co-op students kind of do different presentations on this biodiversity program before, and one of them found that where the cattle were, there was, I don't know, 70% less wildlife, or some I'm just picking a percentage, but it was something like that. I'm just curious about breeding birds.
Yeah, so when they decided on the locations of the ARUs, they put the ARUs in the spots where the wildlife cameras are. So at each site there's a couple of wildlife cameras, so they put them in the same spots as those wildlife cameras just to kind of keep it simple for takedown and setup purposes. Looking at the Google Earth imagery of each site, I would say that they could be set up a bit differently. However, the ARUs need to be 600 meters apart, so you're kind of limited that way with how you're able to space them in your site. So I would say that it kind of needs to be looked into a little bit more, but just from my study and my habitat mapping that I kind of was able to conclude from that I think that not all of the habitat types are being represented by the ARU placements. So I would like to see if the results differ at all next year if the ARUs were placed in different spots. in terms of having different amounts of wildlife or different species richness counts in areas where there were livestock or whatever, I didn't really look into that just for the purposes of my presentation, but I know that the ARU recordings, the software that the ARUs are analyzed by, it splits each noise into separate categories, and that's how you're able to label them, you know, mallard or song sparrow or whatever. And there were some cases where it said livestock or highway traffic. So there was definitely a bit of interference from outside sources on the ARUs.
Quinn, who set up the times that the ARUs would come on? Like, were you part of that? What was the reasoning, or what was the protocol used to set the time periods for recording?
So the time periods for recording, I wasn't part of that. So all of the breeding bird monitoring was done by a third-party consulting company. So I think that what they tried to do was just follow those Alberta Biodiversity Monitoring Institute protocols as closely sort of as they could. I can't remember off the top of my head if that is in the protocols or if that was just sort of their decision, but just in terms of when birds are most frequently calling, I think that was sort of their decision that way. But I can look into the Alberta Biodiversity Monitoring Institute protocols and see if it says anything in there about time of day for you.
So then, do the point count survey people, do they use that same information for the time that they go out?
I think that in terms of the point counts, it was maybe just a little more, not random, but it wasn't planned. Like the ARUs can be programmed like specifically at sunrise. But it was more just the point counts. You get out there and you start your point counts at sunrise, and you do them in the morning, and it takes you 5 minutes to walk from this point count location to this point count location. So, you know, just sort of that way was kind of how I think they did their point count surveys.
Yeah.
When it's Darcy, I was wondering, did you happen to look at species at risk and see if the ARUs versus the point counts were picking up any difference for those special species?
Darcy, you bet I did. I'm glad you asked. This was originally in my presentation and then I had to cut it out. So that made me really sad. But here you go. These were the listed species that were detected during the study. So this is a chart just kind of showing which methods detected which species that are listed. So as you can see, point counts detected most of the species that are listed, and ARUs only detected 3 of those. I think there's 9. 1, 2, 3, 4, 5, 6. Yeah, 9. But the one species that point counts didn't detect was detected by ARUs. And so I also have a little explanation slide. ARUs were unable to detect all of those species that the human observers did, and that's pretty crucial information to understand what sort of listed species, endangered or threatened species you have on your site. Pretty important to know. So kind of the main idea from that is just that having human observers present, it's reinforced that it's so important, and that that one species that ARUs did detect that point counts didn't. It shows you that ARUs are kind of supplementing, like filling in the gaps where maybe point counts are lacking, and I think that's why they go together so nicely.
Yeah, it's a northern saw-whet owl, so you wouldn't expect a point count to pick it up because they're not going out at night, whereas the ARU being deployed a little longer might pick it up. So
yeah, I knew that. Yeah.
You've done a really good job, Quinn. You made it hard on me to come up with any questions, so good on you for that. I guess I'll give you a hard question then.
Oh.
I'm really happy that you brought the habitat in. I really think that complemented and really boosted the power of your presentation and your analysis. So if you were to recommend, you talked about cost a little bit, but I imagine, I think you said they went out for 3 point counts?
Yeah.
And are the people doing the point counts the ones that are deploying the trail cameras and the ARUs?
Yes. Yeah, it would be the same, probably.
So maybe it wouldn't be that much of an additional cost for them to, as we already heard, maybe choose the location of the ARUs a little bit better to take into account the habitat and capture more of the habitat complexity. And there wouldn't be a whole lot of additional cost. You'd have to plan a little bit better at the front end, but you think that's a reasonable happy medium?
Yeah, no, exactly. Like I want to see a little more research done into, like let's look at our site maps, let's go out on site and let's see, like this is where we had the ARUs last year. Maybe this is a better spot for next year. And then to see kind of how those numbers, those species richness numbers compare over those 2 years, and then go from there and kind of make a decision like were the ARUs just being limited by the habitat, or is it just that they're not comparable to point counts in this situation? But yeah, I would, just because all the literature pointed towards ARUs being so up there with point counts, I feel like it would just be kind of the habitat that's limiting them at this point. So yeah, if trained field observers could kind of do the research and then go out there and put them in maybe better representative areas, then I think that's the best bet.
And do you think then if they only did 2 visits, so 2 point counts, one when they deploy and one when they retrieve, do you think that would maybe reduce costs and still get adequate data that is needed?
Reduce costs, yes. But just because your period for when you want to be monitoring your breeding birds is that sort of May, mid to end May to beginning of July, sort of, I think that it's valuable to have a point count surveys done sort of somewhere in there instead of just right at the beginning, right at the end. I feel like you might be sort of biasing the information a little bit by only limiting it to 2. So it's definitely, so because I guess I'm not sure if I mentioned this, but because this is a proactive monitoring program that Husky isn't required to do, they're just doing it to understand what their impact is on the wildlife. I think it would be okay for them to kind of just see what methods are working because the information isn't crucial for them right now. So yeah, that's kind of what I would recommend, I guess.
Great, thank you.
Are there any other questions for Quinn?
Quinn, it's Chris. There's a lot of interest in some of the secretive nocturnal species. Did any of your sample sites have access to wet meadows or wetlands? And is there any program by Husky to monitor, in that sort of midnight to 2 a.m. period?
So are you still meaning like monitoring bird species or monitoring other types of wildlife?
It used to be birds. A yellow rail is a good example of a species that's only really listenable at night.
Okay. Well, I can tell you off the top of my head, yellow rail was not one of the 125 species detected. So no, they don't currently do surveys in that night time frame. I guess I don't really have an answer for you for that one, but I can definitely look into it for you and see what I can come up with. Yeah, I don't have the answer to that. You got me, Chris.
Do you remember in your habitat mapping if you did have a certain proportion of wetlands in some of the areas?
So when I was looking at the Google Earth imagery, I wasn't kind of, just because I wasn't looking for them, I didn't pick them up as much. I know at least one of my sites had a couple of wetlands occurring kind of around some of the point count and ARU locations. So yes, there are wetlands obviously along the North Saskatchewan River, but as for the nighttime count information, that isn't something that they do right now.
This is Trippett. I can help a little bit on that. As far as once operating, I can pretty much say that we haven't done it at nights like that. When they're doing development phases where they're going out and actually deciding where stuff's going to go, I know they're doing frog surveys and amphibian surveys, so that I'm guessing is going to be in your time period so they can see what's there. Yeah, once we're active and it's operating, I'm trying to think along the well fields. I can't think of any wetlands because you're pretty much bordering the river and that are close to it a lot. I can't think of any wetlands that pop out. If there is wetlands, it wouldn't be in super close vicinity to our infrastructure. Like I wouldn't walk past it when you're walking by our infrastructure. You don't walk past any wetlands.
Good, thanks, Trippett.
Yeah.
Thanks, Trippett.
Hey, Quinn, other Quinn here. Do you think only deploying the ARUs during migratory mating season would make them more comparable to the point counts?
What do you mean?
So
Sorry.
like in species detected. So because during migratory mating season, that's when most of the birds are calling. Do you think only deploying them during that time would make them more comparable to point counts?
Just because I'm kind of limited in my knowledge of migratory birds and their period, I would say I don't really have an answer for that one. I'm sorry. But maybe I might just need you to explain it to me better. If you have a chance after this is finished, if you just want to message me kind of, and then I can message you and I can try to find the answer to your question.
Gotcha.
Hey, Quinn, other Chris here. So is there any level of like QA, QC going on with these ARUs? Like it records it, it spits out what birds it thinks it is. At any point, does a human being re-listen to that audio and confirm what it's saying? Or is it just a mature enough technology at this point that we trust it?
So because this is the initial year that that the ARUs were being used, it's a lot more work to get them going. Like, so how it works is the ARUs are smart enough to clump together like noises. So like that call that I played earlier, that was a Tennessee warbler. So all of the calls from all of the recordings from that one ARU, it would clump those all together and tell you this is all the same bird. And then it would clump all of your song sparrow calls and say this is the same bird. And then a trained technician consultant would have to go and
bird brain, I believe, is the technical term.
A trained Chris Olson would have to go in and listen to a couple of those calls and say, okay, this is a song sparrow. And then you label that cluster as song sparrow. So there is like a bit of a sort of human and technology mix in there, but for like next year, because they already have all of those species programmed in saying this cluster is song sparrow, next year the software will just tell you this is how many song sparrow calls you had.
Gotcha. So you just got to train a little bit.
Yeah, exactly. Program the software.
Cool. Thank you.
Mm-hmm.
Well, we've gone 10 minutes over time, but I don't think anyone minded. Does anyone have any other questions, or are we good to close up now? I think we're good. Okay.
Yeah, good job, Quinn.
Wonderful job. Everyone, you can clap or whatever. I do see that there's like the chat thing lit up this time, so you got to take a look at that.
Mm-hmm.
Okay. So if anyone wants to add any comments in there, now's the time so that Quinn can take a look. And Keely, again, I apologize that I didn't have this for you. I'm sorry, I'm learning and I'm just trying to get everything done. And that's great, wonderful feedback. So we'll make sure that you can read all of these, Quinn, before I close up. But that concludes the presentations for today. An invitation will be sent out, or invitations will be sent out on Monday for the 2 upcoming ones on vegetation. Please take the time and fill out the evaluations. And then if you can please get those to me, that would be great. Thank you again, everyone, for joining us today. Trippett, thank you for being the host agency and being a mentor to both Keely and Quinn over the last 8 months. And I know that our students always come up with amazing projects and get to learn an awful lot from you guys. So we really much appreciate Husky for being a host agency to us. We really value that.
Chris, full-time birding is not in my future. This is the extent of my bird knowledge, and now I'm gonna forget about birds forever.
Good to hear.
Not until that final report is submitted, Quinn.
Oh my God. Yeah.
But anyway, people are able to log out. I'm not going to end the meeting yet because I want to make sure Quinn has a chance to read everything in terms of the comments. So thanks again, everybody, and bye for now, and hopefully see you next week.
Thank you, everybody.
So I'll let you, what are we put for abstract number? This is presentation. It's presentation number 3. So I thought that went quite well. Very well.
I think it went good. I think there's a couple things that I might have forgotten to say, but it is what it is.
No, you answered the questions great. The flow was really good.
I just feel bad that there were so many things that I wasn't able to answer, unfortunately.
Yeah, well, I'll email you about that, okay?
Okay, sure.
All right. So I think that's pretty much everyone. Have you read all the comments?
Yeah, I was kind of reading them as we went, so I got to go through them.
Okay, wonderful. So I think that draws this to a close. The only other thing will be great job. And thank you for the kind things that you said as well. I appreciate that. The next steps is that the finished report, I know that you're not going to be able to print. I'll send you the, there's a paper that you need to fill out, and we'll get the hard copy approved, not the hard copy, but your report approved. I think there's still a bit of editing to do.
Yeah.
And you won't have to worry about printing. I'll just accept the digital format. And then once we're up and running again, we'll print that at the print shop at the college, and then you won't need to worry about that at all, okay? But I'll follow up in an email with that. Okay.
Awesome.
All right. So I'm going to end the meeting now. Great job. And thanks for, there's a few people that seem to still be here. And yeah, I'll be in touch. Okay.
Awesome. Thank you.
Job. Have a good day. Okay, bye for now.
See you.